Okay, section 7.3, fractional exponents. So in the end, there's plenty of rules that you can just remember, but I'm going to try to help you realize why things are the way they are, because I'm hoping that might help you remember what's going on. So let's begin. In this class, we have talked about the fact that square root of x times square root of x, radical x times radical x is equal to x. I oftentimes say the square root of something times the square root of something is the something. So I hope you would agree with me that if you had to put an exponent above that x, you'd put a 1. So the question I'm trying to get at is, what would I put above an x to represent those radical x's? And so using the rules that we've seen in the previous sections of this chapter, when I multiply powers of the same base, I add my exponents. So an a plus an a is a 2a is equal to x to the first power. And so now, since there's an x here and an x here, the only way there can be an equal sign here is if this 2a equals that 1. And then, hopefully you can see then that a would have to be 1/2. So, from here on out, you need to always remember that radical x, square root of x, can also be written x to the 1/2 power. And if you ever forget it, you can always play around on your calculator. Now, not everything is square root. Sometimes we have cube roots or fourth roots or whatever other roots. So, just to play that out, if we have the nth root of something, just so that we can have it be a cube root or a fourth root or whatever, basically, in order to get to x, we have to continuously multiply the root n times, and we will then get to x. And so in this case, if I do the same thing I just did, I would have call it x to the a times x to the a times x to the a would be equal to x to the first. But basically, the number of times we'd have to multiply that x to the a would be the n times of whatever this root is. Like if it was a 3, we'd do it 3 times, but just to allow it to be more useful to us for any root, I'm going to put an n there, would be equal to x to the first. So then, using our power of the power, this would be x to the a times n, and since we have the same base, then I could say that a times n has to be equal to 1, which means that a is equal to 1 over n. So, what can I say about that then? Basically, as long as x is greater than or equal to 0 and n is a positive integer, it is a fact then that the nth root of x is always going to be the same as x to the 1 over n. So over here, when we talk square root, we have really 2 as our n, and that's why when we say 1 over n over here, we have a 2. So let's do maybe a simple example just to show you that. So something like square root of 36, another way to write that would be 36 to the 1/2 power, and you'll notice that if you did this on your calculator also, if you took 36 and raised it to the 1/2 power, similar to what you know about square root of 36, you'll get 6. Say it was a cube root of 27, exact same thing as 27 to the 1/3 power, which would be equal to 3. Okay, so let's just extend this a little bit. And let's talk about not just the nth root of x, but let's talk about the nth root of x raised to some power and see what happens. So based on what we learned, this is going to be the same as x to the m raised to the 1 over n power. I mean, basically all we did previously was we had the nth root of x without the m on top. The m would really technically be a 1. So using our power of the power then, we would have x to the m times 1 over n, which would be m over n. So this allows us then to go from this to this. So to go from a radical form to a fractional exponent form. And the way I personally remember this is if someone gives me something in this form here and says write it with a fractional exponent, I always look at it and I say this thing is the root, and this thing is the power. So when I come over here to write this, roots of trees I found down below, And when I think of the word power, it makes me kind of think of like powerful, powerful, standing up, being on the top. So the power thing goes on the top. So it's power over root. Now, there is another way to think about this, and if I go to this position right here, there's really no reason why I couldn't write x to the 1 over n raised to the m power. Because all I'm doing is switching the position, because like 2 times 3 is the same as 3 times 2, m times 1 over n is the same as 1 over n times m. And so what that tells me then, that if I have the nth root of something raised to the power m, it's going to be exactly the same. So what you need to sort of focus on for a second, it's not a big deal, but basically we can write something in this form where we have the power underneath the root, and we take the root, underneath the radical sign. Or over here, this is really the same thing, where we take the root of x and then we raise it to the power. And I'm going to do an example right now to hopefully help you see what I'm talking about. And once again, your calc would always sort of help keep you straight on this stuff. So if we were asked to do something like take the cube root of 125 squared. Well, to me the painful path would be, especially as I'm standing here and my calc, I'm not holding it in my hand, I can access it. But I would probably say, okay, I'll take the cube root of whatever the heck 125 times 125 is, which my head does not know, so I would need a calc. Now I will tell you that what it is 15625. Then I would need a calculator again, because I would say, well, I don't know what the cube root of 15625 is. I might play around with it a little bit, but in the end it's 25. So another way to rewrite this based on what I just said is I could rewrite this as the cubed root of 125 that squared. And I can actually work with that in my head because I've dealt with this cube root enough, and I know that if I take a 5 times a 5 I get a 25 times another 5 gets me to 125. So then I can replace this with 5 and then I just square it, and so 5 squared is 25. So sometimes just having this understanding kind of helps you figure things out when you don't have a calculator. But I do want to just talk about, like, if I just wanted to use my calculator, it's not that hard to use my calc to figure out, put in cube root 125 squared. But now we could rewrite this and say, well, really, what do I know about this? This is the same as 125 raised to the, remember, this guy is a power, so it goes on top, and this guy right here is a root. And so if you fire up your calc and put 125 raised to, and you're going to either put it in fractional mode or else put it in parentheses, 2 divided by 3, you will also get 25. Okay, a couple more examples. A radical 8 times a radical 2. Probably the quickest way to get to what that is equal to is to realize that that is the same as radical 8 times 2, which is the same as radical 16, which is the same as good old 4. So I think you can agree, hopefully, that that is 4. But I just want to play with this a little to prove some of the stuff that we just looked at, that it will all work out the same. So square roots, remember, are the same as raising something to the half power. So this would be the same as 8 to the half times 2 to the half. Now I can't really do anything at this point because I have different bases. But I could for a minute say, well, wait a minute, maybe I could write 8 with the 2 as a base. Because 2 to the third power is exactly the same as 8. But then I still have this to the half power times 2 to the half power. So now what am I going to do? I'm going to rewrite this. So now I have 2 to the 3 times a half would be the 3 halves power times 2 to the half power. And if you don't like fractions, and you can always try this on your calc, would have to be equal to, now I have the same base, and if I take 3 halves and I add a half to it, I get 4 halves, also known as 4 divided by 2, which is 2, which gets us right over there. So you can see this all fits together. And I'll show you another application of it from something we've dealt with. And we have met situations where we are told to rationalize a denominator. And so the method that we used was multiplying by a weird form of the number 1 This is good review. Because I know that if I take a radical 5 times a radical 5, square root of something times square root of something is the something. And the goal is to get that radical out of the denominator. And then on the top, because I have to, this really is the number 1, because it's radical 5 divided by radical 5, so it's not changing anything. So on the top I have 5 radical 5. But in the end, 5 divided by 5 is 1, and I get radical 5. So now with what we're talking about in this section, another way to think about this would be to say that really what this is 5 to the first power divided by 5 to the half power. And knowing what we know from a couple sections back, that when we divide powers of the same base, it's 5 to the 1 minus a half. We subtract our exponents. So this is 5 to the half power, which now, hopefully we're making that connection, is exactly the same as radical 5. Okay, a couple more. Just different ways to start hopefully opening your mind up a little to thinking about how to figure things out. So the cube root of 2 to the 6th would be equal to the cube root of 2 to the 6th. So you could figure it out in your head or use your calc, but 2 to the 6th is 64. And then you maybe have worked enough with cubes now that you realize the cube root of 64 is 4. But just to kind of think of it in a different way, the other thing I could do is just rewrite this as a 2 with a fractional exponent. And once again, I'm going to say the same thing over and over again. This guy's the power. Power is on top. This guy's the root. Roots are on the bottom. And then I can just come across and say, well, 6 divided by 3 is 2. And oh yeah, 2 squared is 4. So keep these options open. There might be different ways to figure these out. Okay. 2 more problems. Sometimes we may be given something in radical form, say 64a cubed b to the 6th, and we may be asked to write as a power with positive exponents. So these next 2 problems are really just about having the ability to go back and forth between fractional exponents and radicals. So to me, I think maybe the easiest approach would just be to say, okay, that really is a 2. Now, hopefully you're going to realize, oh yeah, the square root of 64 is 8, but just to be sort of go across the board here, I'm going to rewrite that as 64 to the half power, power root, times a to the power 3 root 2 times b to the power 6 root 2. And I'm going to just clean this thing up now. So yes, 64 to the half power, square root of 64 is 8. A to the 3 halves, it's reduced as good as it gets. I'm just going to leave it. And then b, I can take that 6 divided by 2 and get a 3. So this is an example where you're given something in radical form and you're asked to put it into fractional exponent form. And so then let me give you another example going the other direction. So instead you may be given something like this. 5 to the 3rd power, a to the 2/3 power divided by 4 to the 1/3 power, and you may be asked to write as a radical in simplest form. So this time we're going the other direction. So same thing, I've got this sort of tape playing in my head. The thing on top is the power, the thing on the bottom is the root. So when I look up here, I notice these guys all have the same root. So basically I want to throw them all under a cube root sign. So now I'm just going to look and see, well, I have a 5 to the 1st power over a 4 to the 1st power, so I have 5/4. And then over here I have my power is a squared. That's fine to write it like that. Another way you could write it is the cube root of 5a squared over 4, if you wanted to make it into one fraction. So that would be it on section 7.3. So your job now is to go to MathXL, for school and for schools and do the 7-3 quiz.